So welcome to the session. In today's class, we are going to discuss some of the limitations of first law of thermodynamics. So here, the limitations of first law of thermodynamics is first law of thermodynamics, what it tells is heat and work are interconvertible, but it has some limitation. So what are those limitations? First one, it does not indicate the direction in which heat flows under the represent panel. Second point, it does not explain why the entire heat cannot be converted into mechanical work. So these are two limitations of first law of thermodynamics. And here PV diagram or indicator diagram. So what it represents is, so that represents so here PV diagram, or you can call this one as indicator diagram ಅಂತಲೂ represent ಮಾಡಬಹುದು. So what it represents is, so one more point you have to remember. So this is the PV diagram, or you can call this one as indicator diagram. So what it represents is, so PV diagram, it is graphical representation of variation of pressure with volume of the system. So first graph ಅಲ್ಲಿ ಏನು ತೋರಿಸ್ತೀವಿ ಅಂದ್ರೆ PV diagram and system expands ಅನ್ನೋದನ್ನ ತೋರಿಸುತ್ತೆ. Second ಅಲ್ಲಿ PV diagram and system is compressed ಅನ್ನೋದನ್ನ ತೋರಿಸುತ್ತೆ. So this is the PV diagram is the graphical representation of variation of pressure with the volume of the system. So pressure is plotted along y-axis and volume is plotted along x-axis. The importance of PV diagram is that, so importance of PV diagram. So what is the importance ಅಂತಂದ್ರೆ, so importance of PV diagram ಏನು represent ಮಾಡುತ್ತಂದ್ರೆ area under PV diagram gives work done during thermodynamic process. ಅದನ್ನ ಯಾವ ತರ represent ಮಾಡಬಹುದು? So that is represented by, so here if you plot the graph of pressure versus volume, pressure is plotted along y-axis and here volume is plotted along x-axis. So this represents area. So here area of the loop is equal to work done ಅಂತ ತಗೊಂತೀವಿ. Area of loop is equal to nothing but work done ಅಂತ consider ಮಾಡ್ತೀವಿ. So importance of PV diagram is that because area under PV diagram gives the work done during thermodynamic process. And next we shall discuss about Carnot cycle. So in order to explain the Carnot cycle, so Carnot cycle, this is one of the important derivation. Definitely they will ask for 5 marks. So this is the diagram we are using in order to explain Carnot cycle. So here the Carnot cycle, it consists of different Carnot cycle consists of different process or different steps. It consists of 4 stages we are going to tell. Carnot cycle. In order to explain Carnot cycle, so we are going to draw the graph of pressure versus volume. So this is A to B represents isothermal process and B to C represents adiabatic expansion, C to D represents isothermal expansion, compression, and D to A again it represents adiabatic compression. So this it becomes complete one cycle. So under Carnot cycle, it consists of 4 stages. Those 4 stages, it consists of 4 stages. So first one is isothermal expansion. Isothermal expansion. Second one, it consists of adiabatic adiabatic expansion, and third one it consists of isothermal compression, and fourth one it consists of adiabatic compression. So note, ಇದರ ಕ್ವೆಶ್ಚನ್ ಹೆಂಗೆ ಹೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ explain Carnot cycle ಅಂತ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ. So when they ask explain Carnot cycle under, first you have to draw the graph of pressure versus volume. So one complete cycle complete ಆಗಬೇಕಂದ್ರೆ it covers from A to B, B to C, C to D, D to A ಬಂದಾಗ ಒಂದು complete cycle ಆಯ್ತು ಅಂತ ಅರ್ಥ. So Carnot cycle, so our Carnot engine works in 4 stages. The stages are explained one by one by using PV diagram ಅಂತ ಕರೀತೀವಿ. So first we are considering by graphically ಅಂದಾಗ ಈ ತರ ಮಾಡಬೇಕು. So or you can explain by considering 1 mole of perfect gas in a cylinder which is fitted with frictionless piston. So it is working in 4 stages. First one isothermal process, second one adiabatic process, third one isothermal compression, fourth one adiabatic compression. So we shall discuss one by one what it happens ಅನ್ನೋದನ್ನ we shall discuss. So in isothermal process, first stage ಯಾವುದು isothermal process, isothermal expansion ಅಂತ ಕರೀತೀವಿ. So first stage is isothermal expansion. Isothermal expansion ಅಲ್ಲಿ ಏನಾಗ್ತೈತಿ? So in this isothermal expansion, second one adiabatic expansion. Second one is adiabatic expansion. Third one isothermal compression. Fourth one adiabatic compression. We already ತೋರಿಸಿದ್ದೀವಿ. So this is the first stage. This is second stage, and this is third stage, and this is fourth stage. Aವಾಗ ಒಂದು complete cycle ಆಗ್ತದೆ. So this arrow mark indicates, so the process ಅನ್ನು indication ಮಾಡ್ತದೆ. So first we shall discuss about isothermal expansion. So in isothermal expansion, cylinder is placed on the source maintained at temperature T1, and the gas is allowed to expand isothermally. So during this expansion, gas absorbs Q1 amount of heat from the source at constant temperature T1 Kelvin. So this isothermal change is represented by the curve AB. So just a diagram observe ಮಾಡಿ. So this represents ಏನದು isothermal expansion represent ಮಾಡ್ತೀವಿ. And next second process ಯಾವುದು adiabatic expansion discuss ಮಾಡೋಣ. ಅಂದ್ರೆ ಯಾವುದು ಇದು adiabatic expansion. Adiabatic expansion ಅಲ್ಲಿ ಏನಾಗ್ತೈತಿ? Cylinder is placed on insulating stem and gas is allowed to expand adiabatically till temperatures falls from T1 to T2. And this adiabatic expansion is represented by the curve B to C ಅಂತ ತೋರಿಸ್ತೀವಿ. So next we shall discuss about isothermal compression. So isothermal compression ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ cylinder is next placed on the sink maintained at temperature T2 here, and here the gas is compressed isothermally. During this process, certain amount of heat Q2 is rejected to the sink. So this isothermal compression is represented by the curve C to D ಅಂತ represent ಮಾಡಿದ್ವಿ. So this is isothermal compression. Next, fourth step for adiabatic compression. So again, cylinder is placed on non-conducting stand. Gas is compressed adiabatically till it returns to initial stage A point. So this adiabatic compression is represented by the curve D to A. So that is adiabatic process. The curve A, B, C, D, A. Notice the curve A to B, C, B to C, C to D, D to A. Complete one the cycle ಆಯಿತು ಅಂದಾಗ, so ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ Carnot cycle ಅಂತ ಕರಿತೀವಿ. Area of the group ABCDA gives total work done per cycle. So this is all about Carnot cycle. And the next ಯಾವ ತರ ಕ್ವಶನ್ ಕೇಳಬಹುದು? So they may ask next. So next important derivation ಯಾವ ತರ ಕೇಳಬಹುದು? Prove that neta is equal to 1 minus T2 by T1 in case of Carnot working in the Carnot cycle. Prove the equation neta is equal to 1 minus T2 by T1 ಅಂತ ಕೇಳಿದ್ರೆ ಸೊ ಯಾವ ತರ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? ಸೊ ಇದನ್ನ ಬೈ ಗ್ರಾಫಿಕಲ್ ಆವಾಗಲೇ ಮಾಡಿದ್ದು ಬೈ ಗ್ರಾಫಿಕಲ್ ಮೆಥಡ್. ಸೊ ಇದನ್ನ ಯಾವ ತರ ಬೈ ಡೆರಿವೇಶನ್ ಮೂಲಕನೂ ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸ್ಬೋದು. ಏನು? ಪ್ರೂವ್ ದ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ neta is equal to of Carnot cycle efficiency neta is equal to 1 minus T2 by T1 ಅಂತ ತೋರಿಸ್ತೀವಿ. So here again it consists of 4 stages. So the first stage in the Carnot cycle ಯಾವುದು? That is the first stage in the Carnot cycle is isothermal expansion. So first stage isothermal expansion, we are considering 1 mole of gas. So taking in stage from P1 V1 T1 to P2 V2 into T1 irutta. So alli enaagtೈತಿ heat absorbed from the source at constant temperature T1 anna, that is represented by Q1 is equal to W1 ಅಂತ ತಗೊಂತೀವಿ, that's equal to RT1 log of V2 by V1 ಅಂತ represent ಮಾಡ್ತೀವಿ mathematically. So let us consider this one as equation 1. ಇದೇ ತರ ಸೊ 4 ಸ್ಟೇಜಸ್ ಅಲ್ಲಿ ಯಾವ ತರ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗ್ತೈತೆ ಅಂತ ಮ್ಯಾಥಮೆಟಿಕಲಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ how we are going to derive or how we are going to show the efficiency neta is equal to 1 minus T2 by T1 ಅನ್ನೋದನ್ನ ನೋಡೋಣ. This is the first stage. And the second stage ಅಲ್ಲಿ so second stage ಯಾವುದು? The second stage is so second stage. So second stage in the Carnot cycle ಯಾವುದು ಬರುತ್ತಾ? Adiabatic. Second stage is adiabatic expansion. So adiabatic expansion only. So 1 mole of gas taking place. It stays from P2 V2 into T1 to it is taking place from P2 to P3 and V2 to V3 and T1 to T2 ಆಗುತ್ತೆ. So the heat rejected Q2 by the gas to the sink at constant temperature T2 is given by the formula Q2 is equal to W3 in the second stage expansion of 1 mole of gas takes place from P2 V2 T1 to P3 V3 T2. Therefore work done by the gas is given by the formula. So that is given by the formula. How can we represent? So mathematically it is given by the formula W2 is equal to R in the bracket T1 minus of T2 whole divided by gamma minus of 1 into the equation 2 and 1. And the third stage of the in the Carnot cycle isothermal compression. So third stage of the isothermal compression. So in third stage isothermal compression, 1 mole of gas takes place from So here the third stage it takes place in isothermal compression. So in that 1 mole of gas takes place in stage from P3V3T2 to P4V4. Temperature is maintained at T2. The heat rejected Q2 by the gas to sink at constant temperature T2 is given by the formula. Third stage only. So here heat rejected by the gas to the sink at constant temperature T2 is given by Q2 is equal to W3 and the work done at the moment. That is represented by RT2 log of to the base E V3 divided by V4 of the 3. Let us consider this one as equation 3. In a fourth stage of the 3, so the fourth stage is yaudu, that is of Carnot cycle is adiabatic compression anta tagotivi. So in adiabatic compression of 1 mole of gas takes place. So it takes place from P4, V4 and T2 to P1, V1 and T1. So therefore work done on the gas is given by the formula. So W4 is equal to R in the bracket T1 minus of T2 whole divided by gamma minus of 1. Let us consider this one as equation 4. Next node, first stage ಆಯ್ತು, second stage ಆಯ್ತು, third stage ಆಯ್ತು, fourth stage ಆಯ್ತು. ಹಂಗಂದ್ರೆ by using all these equations, ಎಲ್ಲಾ equation ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು so next ಏನ್ ಮಾಡ್ತೀವಿ, efficiency ನ ಯಾವ ತರ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ನೋಡೋಣ. So efficiency neta is given by the formula. So efficiency neta is equal to, ನಮಗೆ ಗೊತ್ತಿದೆ formula is output work divided by heat supplied. So output work is denoted by Q1 minus of Q2 whole divided by heat supplied is nothing but Q1. So ಇದನ್ನ ಹೆಂಗೆ ಬರೀಬಹುದು, Q1 by Q1 minus of Q2 by Q1 ಅಂತ ಬರೀಬಹುದಾ. ಸೊ ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಏನೇನಂತ 1 ಉಳಿತೈತಿ, 1 minus of Q2 by Q1 ಅಂತ ಬರೀಬಹುದು. Let us consider this one as equation 5. ಆಮೇಲೆ next 1 and 3 put equation 1 and 3 equation 5 ಒಳಗೆ substitution ಮಾಡಿದ್ರ ನೋಡ್ರಿ, 1 equation 1 ಫಸ್ಟ್ ಇದ್ರಲ್ಲಿ ಬರುತ್ತೆ, equation 3 ಇದು, ಆಮೇಲೆ ಇವು ಎರಡನ್ನೂ ಎದ್ರಾಗ ಹಾಕಬೇಕು, equation ಈ 5 ಒಳಗೆ substitution ಮಾಡ್ರಿ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, efficiency neta is equal to 1 minus of RT2 log of to the base E in the bracket V3 divided by V4 whole divided by RT1 log of V2 divided by V1. This is equation 6 ಅಂತ ತಗೋತೀವಿ. Next for adiabatic expansion ಗೆ, for adiabatic expansion ಗೆ we know dV raised to gamma minus 1 andra constant anta tagotivi. So in the second stage olaga, so in the second stage for adiabatic, in second stage for adiabatic expansion, so that is given by T1 V2 raised to gamma minus 1 is equal to T2 V3 raised to gamma minus 1. So ಇದನ್ನ ಹೆಂಗೆ ಬರೀಬಹುದು, so that is also represented as T2 by T1 is equal to V2 raised to gamma minus 1 divided by V3 raised to gamma minus 1, V2 divided by V3 whole raised to gamma minus 1 ಅಂತ ಬರೀಬಹುದಾ. So V2 by V3 is equal to T2 by T1 whole raised to 1 minus of gamma minus 1 into 2. Let us consider this as equation 7. ಅದೇ ತರ for fourth stage, in fourth stage for adiabatic compression, ಗೆ ಯಾವ ತರ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? T2 V4 raised to gamma minus 1 is equal to T1 V raised to gamma minus 1. So ಅದನ್ನ ಹೆಂಗ್ ಬರೀತೀವಿ? So T2 divided by T1 is equal to V1 by V4 raised to gamma minus 1. So that's equal to V1 by V4 whole raised to gamma minus 1. ಇದನ್ನ ಹೆಂಗ್ ಬರೀಬಹುದು? V1 by V4 is equal to T2 by T1 raised to 1 divided by gamma minus 1 ಅಂತ represent ಮಾಡಬಹುದಾ? So consider this one as equation 8. ಅದಾದ್ಮೇಲೆ comparing equation 7 and 8. ಆವಾಗ ಏನಾಗ್ತದೆ? V1 by V4 is equal to V2 divided by V3 is implies V3 by V4 is equal to V2 divided by V1. In equation 9 ಅಂತ ತಗೊಳ್ಳೋಣ. So next put equation 9 in equation 6 or substitution ಮಾಡಿದ್ರ we got efficiency eta is equal to 1 minus T2 by T1 ಅಂತ prove ಮಾಡ್ತೀವಿ. So this is one of the important derivation. Definitely they will ask for 5 marks ಕೇಳ್ತಾರೆ. So ಯಾವ ತರ ಇದು ಮಾಡಬಹುದು ನೋಡಿ. ಇದು ಒಂದು ಸ್ವಲ್ಪ ಲೆಂದಿ ಅನ್ಸುತ್ತೆ, but it is very easy if you understand. So first ಏನ್ ಮಾಡ್ತೀವಿ? ಇಲ್ಲಿ ನಾವು ಏನು ತೋರಿಸಕ್ಕೆ ಹೊಂತೀವಿ ಅಂತಂದ್ರೆ efficiency eta is equal to 1 minus T2 by T1. Second stage adiabatic process, mathematically it is represented as it takes place from T2 V2 T1 to P3 V3 T1. ಅಂದ್ರೆ temperature maintained at T1 to T2, pressure P2 ಇದು P3 ಆಗುತ್ತೆ, V2 ಇದು V3 ಆಗುತ್ತೆ. ಇದು ಗ್ರಾಫಿಕಲ್ ಕೂಡ ತೋರಿಸಬಹುದು. So work done is given by W2 is equal to R in bracket T1 minus of T2 divided by gamma minus of 1 ಆಯ್ತು. equation 2 ಅಂತ. In third stage ಯಾವುದು? isothermal compression takes place in the region P3 to P4, V3 to V4, T2 to temperature same ಇರುತ್ತೆ. So QP is represented as W3, that's equal to R T2 log of V3 by V4 ಅಂತ ಹೋಗ್ತೀವಿ. Fourth stage is adiabatic compression. Work done is given by W4 is equal to R in the bracket T1 minus of T2 divided by gamma minus of 1 ಅಂತ ಹೋಗ್ತೀವಿ. And similarly efficiency eta is equal to output work divided by heat supplied is given by 1 minus of Q2 divided by Q1. So equation 1 equation 3 substituted in equation 5 ಒಳಗೆ ಹಾಕಿದಾಗ eta is equal to 1 minus of R into log of V3 by V4 to the base A whole divided by R T1 log of V2 by V1 to the base A. Equation 6 ಅಂತ ಹೋಗಿ for adiabatic expansion TP raised to gamma 1 is equal to constant ಅಂತ ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. So in the second stage adiabatic expansion T1 V2 raised to gamma minus 1 ಅಂದ್ರೆ T2 V2 raised to gamma minus 1 ಅಂತ ಹೋಗ್ತೀವಿ. So ಅದನ್ನ substitution ಮಾಡಿ simplify ಮಾಡಿದಾಗ V2 by V3 is equal to T2 by T1 raised to 1 minus gamma minus 1 divided by gamma minus 1 ಅಂತ equation 7 ಅಂತ. Fourth stage ಒಳಗೆ adiabatic compression ಆದಾಗ T2 V4 raised to gamma minus 1 is equal to T1 V1 raised to gamma minus 1 ಆಗುತ್ತೆ. ಅದನ್ನ ಹೆಂಗ್ ಬರೀತೀವಿ? T2 by T1 is equal to V1 by V4 raised to gamma minus 1 ಇದೆ, ಅದನ್ನ ಕಾಮನ್ ಆಗಿ ತೆಗೆದಿದ್ದೀನಿ. ಸೊ V1 by V4 ಏನಾಗುತ್ತೆ? T2 by T1 raised to ಅದನ್ನ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಇಂದ ರೈಟ್ ಹ್ಯಾಂಡ್ ತಗೊಂಡಾಗ 1 divided by gamma minus of 1 ಅಂತ ಆಗುತ್ತೆ. equation 8 ಅಂತ ತಗೊಂಡ್ವಿ. So comparing equation 7 and 8 ಅನ್ನು ಕಂಪೇರ್ ಮಾಡಿದಾಗ V1 by V4 is equal to V2 by V3 or V3 by V4 is equal to V2 by V1 ಅಂತ ಹೇಳ್ಬೋದು. Put equation 9 in equation 6 ಒಳಗೆ ಹಾಕಿದಾಗ efficiency eta is equal to 1 minus T2 by T1 ಅಂತ ಹೇಳ್ಬೋದು. This is one of the important derivation. Definitely they will ask for 5 marks. So So try to practice this one. So next, second law of thermodynamics we shall discuss. So what the second law of thermodynamics? It states, let us see that one. So here, second law of thermodynamics. So second law of thermodynamics, what it represents andre. So what is the statement of second law of thermodynamics? Actually, second law of thermodynamics is given by two statements, that is Clausius statement and Kelvin statement of the error statement ಮೂಲಕ we are going to represent. So here, according to second law of thermodynamics, that is given by two statements. First one Clausius statement and the second one Kelvin Planck statement and the. So in second law of thermodynamics, Clausius statement, what it states is it is impossible to transfer the heat from cold body to hot body without any external work ಅಂತ ಹೇಳ್ತೀವಿ. Other Kelvin Planck statement ಏನಂತಂದ್ರೆ it is impossible to get continuous supply of work by cooling a body to a temperature below the coldness of the surrounding ಅಂತ ಹೇಳ್ತಾರೆ. So these two statements we are going to call that one as second law of thermodynamics. So give the statement of second law of thermodynamics or state second law of thermodynamics. You have to mention both the statement, that is Clausius statement as well as Kelvin Planck statement. They are going to represent one. So next we shall discuss about refrigerator. So nothing but heat pump. So the meaning of refrigerator or schematic diagram of refrigerator is given by like this. So this is the schematic diagram used to represent the refrigerator. So here refrigerator is also called as a heat pump anta karithivi. So this is also called as heat pump anta karithivi. So what is the meaning of refrigerator antandre? So it is one of the, it is device, it is a reverse of heat engine anta karithivi. So it consists of cold reservoir, nothing but sink, and hot reservoir which is maintained at temperature 1, and it consists of working substance. So how you explain ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, so in this, so this diagram is also called as a heat pump. It consists of cold reservoir, hot reservoir, and working substance. So explain schematic diagram of refrigerator. First you have to draw this diagram and you have to explain in one words. So it consists of cold reservoir, working substance, and hot reservoir. So refrigerator transmit heat from cold body to hot body. According to second law of thermodynamics, heat cannot be transferred from cold to hot body without doing work. Therefore, work must be done on the working substance to transfer the heat from sinks to source. So from this, W is nothing but, so that is work done on the working substance on TV. And next, that is Q2 is nothing but heat energy absorbed by the working substance from sink and TV. So Q1 is nothing but, no, Q1 is Q2. So Q1 is nothing but heat energy released to the hot substance, and it is given by the formula. So Q1 is equal to W plus of Q2 ಅಂತ represent ಮಾಡ್ತೀವಿ. So therefore working substance used in refrigerator ಯಾವುದು ಇರುತ್ತಾ? Freezing ಇರುತ್ತಾ, freezing gas. So freezing gas use ಮಾಡ್ತೀವಿ working substance. And coefficient of performance of refrigerator ಹೆಂಗ್ define ಮಾಡ್ತೀವಿ ಅಂದ್ರ, that is, it is defined as ratio of work extracted from cold body to work done on the working substance. And mathematically ಯಾವ ತರ represent ಮಾಡ್ತೀವಿ ಅಂದ್ರ, so mathematically it is represented as alpha is equal to So Q2 divided by W. Q2 ಅಂದ್ರೆ ಏನ as it is ಇರ್ತೀವಿ. W ಅಂದ್ರೆ Q1 minus of Q2 ಅಂತ represent ಮಾಡ್ತೀವಿ. Q1 is nothing but work extracted from whole body. So Q2 ಅಂದ್ರೆ work extracted from whole body. Q1 is nothing but heat released to the hot reservoir. W ಅಂದ್ರೆ work done on the working substance ಅಂತ ತಗೊಳ್ತೀವಿ. So formula for coefficient of performance of refrigerator is given by this mathematical formula. So that is alpha is equal to Q2 divided by W, or that is also represented as Q2 divided by Q1 minus of Q2. ಇದನ್ನ ಹೆಂಗ್ ಬರೀಬಹುದು ಅಂದ್ರೆ ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ ರೇಷಿಯೋ ಆಫ್ ವರ್ಕ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟೆಡ್ ಫ್ರಮ್ ಹೋಲ್ ಬಾಡಿ ಟು ದ ವರ್ಕ್ ಡನ್ ಫ್ರಮ್ ದ ವರ್ಕಿಂಗ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಂತ represent ಮಾಡಬಹುದು. So this is all about schematic diagram of heat pump, or it is also called as refrigerator, and mathematically ಯಾವ ತರ represent ಮಾಡ್ತೀವಿ and how it is working ಅನ್ನೋದನ್ನ. So diagrammatically we can possibly explain about schematic diagram of refrigerator. Explain the schematic diagram of refrigerator. Sometimes they may ask for 3 marks, or sometimes they will ask for 5 marks. So this is all about working of refrigerator and efficiency of that refrigerator. Mathematically it is represented as coefficient of performance of refrigerator, or formula for coefficient of performance of refrigerator ಅಂದ್ರೆ ಈ formula represent ಮಾಡಬಹುದು. ಏನು alpha is equal to Q2 divided by W. That's equal to Q2 divided by W ಅಂದ್ರೆ ಹೆಂಗ್ ಮಾಡಬಹುದು? That is also represented as Q1 minus of Q2 ಅಂತ represent ಮಾಡಬಹುದು. So I hope you got this one. Try to practice all these things. So if you are having any doubt, just put in the